Hey guys, welcome back to another video. In this video, we're going to talk about and answer one of the hardest question from the mechanics paper of A-level maths. And at least to me, in my opinion, this seems to be one of the hardest from I've gone through around 11 years of QP while prepping for my M1 exam, and this to me seemed like literally one of the hardest, most complicated yet so creative question that I have at least come across. In this entire question, you need idea from friction, you need a strong idea of kinematics, because that is mostly what you're going to use in part B. And in part C, you need idea of momentum. And part A and C is not that difficult. It's very straightforward, very easy. But the hard part to this question is the part B, right? And if you're prepping for M1, I'm pretty sure you've already come across this question. But if you have not, do try this question out before watching this video. But I can somewhat guarantee you won't be able to solve part B. But still, try it out yourself. And this is the paper code 9709 winter 21 and paper 42. Now, I believe this year there was no real life exams taken due to COVID year. So I guess that's why they made this atrocity of a question. But well, we're going to solve this question step by step. I've already done it. So I'm going to try and explain this over here. So let's read the question first. What does it say? This is question 7. So it says particles P and Q have masses m, and 2m kg respectively. So particle P has mass m, particle Q has mass 2m. Great. Now the particles are initially held at rest 6.4 meters apart on the same line of greatest slope. Great. So on this slope, they are set apart by a distance or displacement of 6.4 meters. Great. Now, the angle of this slope with respect to the horizontal is alpha. Alpha. Great. Now, they're telling you sine alpha is 0.8 and particle P is released from rest and slides down the line of greatest slope. Therefore, down the slope from rest, particle P is going to drop, right? Okay. Now, what else does it say? Simultaneously, particle Q is projected up the same line of greatest slope at a speed of 10 meters per second. Okay. So they're telling you while P drops from rest, that is 0 meters per second, it's going to drop due to gravity. It's going to drop down, and at the same time, they're telling you they have pushed particle Q up the plane with an initial velocity of positive 10 meters per second. The first thing to understand from this question is they're considering upwards as positive and downwards as negative, right? They're projecting Q upwards with a positive 10 meters per second. And the next thing is they're telling you, okay, the coefficient of friction between each particle and plane is 0.6. Therefore, both the particles are made up of the same material. And the slope, the same slope, which is why for both cases, the coefficient of friction turns out to be 0.6. They've given you that data. So question A, what they're asking you is, show that the acceleration of Q up the plane is negative 11.6 meters per second square. So notice initially I had mentioned that upwards they're considering to be positive and downwards as negative. Therefore, if I draw the diagram again and I consider this particle to be Q, you know this particle Q has been given an upwards velocity of 10 meters per second, positive 10 meters per second. Therefore, it's going to travel upwards. Therefore, motion is upwards. Where will the friction act though? You know, this is a frictional surface, right? There is friction on the surface of the plane. They've given you the coefficient of friction, right? Therefore, where is the friction going to act? Downwards. Fair enough. Because the motion is upwards. The motion of the ball is upwards. Now, the component of weight will also act downwards due to gravity. So this is your resultant weight, and this is broken down into two components. That is, one is vertical, the other is horizontal or parallel to the slope, whatever you want to call it. And this is going to be used for your resultant force acting downwards, right? So they want to they want you to find out the resultant acceleration of the point particle q. Now, for that, what you're going to do is you're going to equate resultant force is equals to ma, right? So resultant force F is equals to ma, right? So what is the resultant force? So what are the only forces acting on this point particle? The only forces acting on this point particle are the weight acting downwards and also friction acting where? Downwards. So we are going to consider both of those forces to calculate its acceleration, right? And the acceleration, notice, is downwards. That is why compared to up the plane, the value is negative, right? Since it's a vector, compared to up the plane, it is negative, right? So it's going to be a negative value. So friction acts downwards, your weight component acts downwards, both of those values are going to be negative. Therefore, minus Fr, that is your friction, minus your component of weight, W denotes weight, sine alpha. Now, notice one thing about alpha, that is, if this was your plane, and this is alpha, notice, this is going to be alpha as well. Now, if you don't know this, you should watch this video, right? So, since that is alpha, this sine alpha, they've already given you the value of sine alpha, that is 0.8. And I can also break this down to understand what cos alpha is going to be. Sine alpha is 8 by 10 if I simplify 4 by 5. So, opposite by hypotenuse, your hypotenuse is going to be what? 5. And your opposite side is going to be 4. So, you can find out what the adjacent side is. That's going to be, if you use Pythagoras theorem, it's going to be 3, right? So, if you want to find out cos, which is adjacent by hypotenuse, adjacent is 3, divided by hypotenuse, that's going to be 5. So, your value turns out to be 0.6. So, you know the cos alpha value, you also know the sine alpha value. Now, let's find out what? The resultant acceleration. So, for the friction, notice, by the way, it's going to be, what is the mass of Q? It's going to be cancelled off, but still I'm going to write it, 2ma. I'm going to find what? I'm going to find the acceleration, A. Great. Now, for the friction, notice, how are you going to write the friction expression? You're going to write it as mu, that is coefficient of friction, times your vertical component of weight, that is your weight acting downwards, hence your normal contact force is going to be upwards. So this is your normal contact force. Great. So your normal contact force is going to be, how much is going to be? It's going to be, you know the value of cos alpha. So it's going to be 2m times your g, this is your weight, 2mg, times cos alpha, since you want this component, because normal force is going to be exactly this component, but in opposite direction, right? Cos alpha minus 2mg sine alpha is 2ma, right? Now, notice one thing, all the 2m is going to be cancelled off, right? 2m, 2m, 2m. And your final answer is going to be 0.6 times, notice gravity in case of mechanics is 10. So 10 and it's going to be 0.6 times, what was it? 10 times it was 0.8. So 0.8 is going to be acceleration. Now if you calculate this out, minus 0.36, so minus 3.6 minus 8, it's going to be minus 11.6, right? Okay. So this is your acceleration value. Acceleration will be minus 11.6 meter per second square. Great. So now part B. Find the time for which the particles are in motion before they collide. So the question is asking you, how long would have been passed before point particle P falling down and point particle Q that had been given a velocity upwards, how long would it take for both of these particles to come in contact? Now, this is where the atrocity begins. Now, in a normal case, what you would imagine would happen is P would fall down, Q moves up, at some displacement over here, at some distance over here, they're supposed to meet, come in contact. However, this question took a different turn. What turn, you ask? The question, in reality, what is happening in this scenario is P is falling down, Q is moving up, but since Q is decelerating, it's going to reach velocity 0 at some point over here, that is 0 velocity, meter per second, while P falls down. And from this point onwards, Q is going to accelerate downwards. Therefore, while there remains a gap between particle P and particle Q, both of them now starts moving downwards. Therefore, while both of the particles P and Q move downwards, at some point in time in that scenario, they're going to come in contact. So they're not going to come in contact while P is falling down and Q is moving up. The Q would actually reach velocity 0 and start moving down, and while that motion of both particle P and Q are going to come in contact. That is what's happening in reality. Now, in this case, in this question, when you're going to answer this question, you're going to consider 3 cases that can happen. A, P falls down, Q moves up, and they meet. Second, P is going to fall down, Q is going to move up, and Q is going to reach velocity 0, while P is going to continue falling down, and Q also changes its direction and moves down. And in that scenario where both of the particles are moving down, in that case, they're going to come in contact, let's say, somewhere over here. So those are the 2 things that can happen, right? Now, in our case, this is what's happening. However, while answering the question, you wouldn't know that. Therefore, you're going to answer this question in a few steps. You're going to consider the cases for both the particles, what their velocity is, what their acceleration is, what displacement they're going to cover, granted they don't come in contact. So let's break it down and understand for particle Q and particle P what's going to happen. So for particle Q, since you've given it a velocity upwards of 10 meters per second, you know with a velocity 10 meters per second upwards and a net resulting force downwards, it's going to decelerate, right? So it's going to reach velocity 0 at some point upwards. So I'm going to find out what that displacement is going to be. At what point, at what displacement above this point is it going to reach velocity 0? That's what I'm going to find out, right? So V square is equals to U square, and we'll use this formula plus 2as. I know the final velocity is 0. At some point it has to be 0. Then the other thing is U square, initial velocity upwards, hence positive, 10 square minus 2 times acceleration acting downwards, hence the negative side, times S, the displacement that I'm going to find out. That is going to be somewhat around here. This is going to be your S. So this block is going to move upwards and reach this position, let's say, right? Now this S is going to be your displacement. That's what I'm finding out for Q. Now this S turns out to be 4.31. So at the point where velocity is 0, the displacement from initial position is 4.31. Therefore, if this is 4.31, if I subtract that from 6.4, 6.40 minus 4.31, that's going to be 0.9. So 2.09 is the distance between initial position of P and final position of Q. Now let's see how long the particle Q is going to take to reach this position. That is 4.31 meters above. So your final velocity, is 0 for Q. The initial velocity to be positive, then the acceleration to be downwards, and you're going to find out T. Let's find out T. This T turns out to be 0.862 seconds. Therefore, after 0.862 seconds, you're going to see the particle Q is going to reach this position. Right? So, after 0.862 seconds, it reaches this position. That is 4.31 meters. So, I've understood what's going to happen in case of particle Q. Now, let's see for particle P what's going to happen while Q moves upwards. Right? Fair enough. For P, I'm going to first find out its acceleration, that is its weight acting downwards and friction acting upwards. So there's going to be a net force downwards. That is, it's going to accelerate downwards. So what is that? Acceleration downwards. You're going to take, this is most likely the weight component, and this is going to be most likely your friction component. Yeah, this is your friction. So this is your component of weight acting downwards. That is mg, mass is m, and g is going to be 10. So 10m times your component is going to be sine alpha, right? Why is it going to be sine alpha, you ask? So this is alpha, and this is going to be sine alpha, and this is going to be cos alpha, right? So sine alpha, is 0.8. Therefore, this is going to be your weight component, and this is going to be what? This is going to be your friction. Now, since friction is in the opposite direction compared to your component of weight, it's going to be 0.6 coefficient of friction times your weight, 10m, that is mg, times your component, that is going to be cos alpha, which we found out to be 0.6, right? Cos alpha. So when you calculate all of this, your mass is going to be cancelled off again, and your acceleration turns out to be 4.4 meter per second square. Great. So P is accelerating downwards at a rate of 4.4 meters per second square. Great. Now, for P, within this time, 0.862 seconds, that Q is moving up. How far will P fall down? So while Q is reaching velocity 0, how far will point particle P move down? That is what I'm going to figure out right now. I'm going to see if it's going to meet Q or go beyond this position or go beyond this position. Therefore, will it meet before Q reaches velocity 0, or will it have a gap in between? That's what I'm going to find out. So I'm going to find out within this time, this T, what is P's displacement? Let's find that out. So S, I'm going to find out ut, the initial velocity to be 0 because it's dropped from rest. So 0 plus half times A, acceleration you just found out, 4.4 times T square. Your time squared to be 0.862 seconds. Great. So now calculate for displacement. That turns out to be half times acceleration times T square. And this displacement turns out to be 1.635 meters. And what do you know? The particle Q moves up by 4.31 meters. Therefore, while P was here, Q was here, Q will move up by around 1.635. Sorry. P will move down by 1.635 and Q will move up by 4.31. 4.31 meters. Now notice one thing. You knew the total gap in between both the particles is 6.4 meters. Great. So now let's add up both these displacement, P moving down and Q moving up. Let's see if that adds up to 6.4. If it adds up or is more than 6.4, that means while both of those were approaching each other, they had come in contact. If it is less than 6.4, that means they did not come in contact within the 0.862 seconds, right? Great. So let's find out the total displacement. The total displacement is going to be 1.635 plus 4.31. That turns out to be 5.945. And this is where this question becomes more difficult. Since they don't meet, I have to now find out at what time more than 0.862 seconds will they come in contact, right? So after the initial 0.862 seconds, they're going to travel further down and come in contact. Great. So the displacement I know to be 5.945 total displacement, and it should have been 6.4 to come in contact. However, it's not that. Therefore, we're going to find out this gap. I'm going to mark it with red. This gap in between, or this gap in between, notice. What is this gap? The gap left by both the particles to come in contact, right? P moved down, Q moved up, there's still a gap because it's less than 6.4, we noticed. How much less? It's going to be 6.4 minus 5.945. The total displacement by both the particles, you're going to subtract that from the required displacement. And that turns out to be 0.455. So this gap in between is 0.455 meters. Now, since you know there's a gap between both the particles, you're going to find out what is the velocity of P and this position. Because you know the velocity of Q, that is 0 meter per second. Because after 0.862 seconds, it reached a velocity of 0. That is what we have calculated. Therefore, we know the velocity of Q, 0 meters per second. We don't know the velocity of P though. What is P's velocity? And that displacement. So, after 0.862 seconds, what is the velocity of P? Let's find that out. So, we're going to find out the velocity of P, that is V, final velocity, initial velocity again 0, acceleration you know 4.4, and time 0.862 seconds. Because we found the displacement in between both of them after 0.862 seconds. After 0.862 seconds. So we're going to find out the velocity after 0.862 seconds. Right? Great. So now I know that at this position where the gap in between them is 0.455 meters, the velocity of P is 3.8 meter per second, or to be specific 3.7928 meter per second downwards, and the velocity of Q is 0 meter per second. Now notice, P is going to, with this velocity 3.8 meter per second, it's going to continue accelerating downwards, right? It's going to accelerate at a rate of 4.4 meter per second square downwards, while Q will also accelerate downwards at a rate of 4.4 meter per second square. Why, you ask? Because remember, I just told you that it doesn't matter what the mass of both particles are. Q has a mass of 2m, P has a mass of m. Doesn't matter. Mass gets cancelled off when you calculate acceleration. Therefore, while falling down, both of them will have the same acceleration downwards. P will have the same acceleration downwards. Q will also have the same acceleration downwards. Now, you might ask, so in case of Q, why was the initial deceleration different? That is because Q was moving up. Friction was acting downwards. Weight was also acting downwards. Which is why your deceleration was greater, minus 11.6. In case of acceleration, notice, both the particles are moving down. So friction is moving up, both in opposite direction. Therefore, weight down, friction up, which is why your acceleration is different. But in this case, since both of the particles of same material, that is same friction of coefficient, is going to have the same acceleration downwards. Since same slope, same friction, same acceleration downwards. It does not matter what mass it is. Great. So you know, from this point onwards, particle P accelerates at the same rate compared to your particle Q accelerating at the same rate. So you will now ask me, how will they ever meet? If P accelerates at 4.4 meter per second square and Q also accelerates at 4.4 meter per second square, how can they meet? Therefore, after 1 second, the speed of P is going to be, let's say, 4.4 plus 3.8, that's going to be 8.2. So, speed of P after 1 second is going to be, speed of Q after 1 second is going to be 4.4 meter per second. After 1 second, add 4.4 to both. Now notice one thing over here. Even though both the particles are accelerating at the same rate, P has an extra amount of velocity since it started moving downwards before Q did. Notice Q has an initial extra bit of velocity downwards compared to Q. Therefore, this velocity is going to cover up this distance 0.455 meters. Therefore, I can say that the resultant velocity, relative velocity between both, is always going to remain 3.8 meter per second. Because since both are accelerating at the same rate, they're gaining the same amount of velocity every second. Therefore, this difference between both the particles are going to remain always constant. Because this is the extra bit of velocity that P has in comparison to Q. Therefore, that distance that you see between P and Q is going to be covered up by this velocity 3.8 meter per second. So I can form an equation saying, while my velocity is 3.7928 meter per second and the displacement I want to cover is 0.455 meters, how long would I take? S is equals to d by t, that is speed is equals to d by t, and my answer, I know for a fact, is going to be t is equals to 0.12 seconds. Therefore, after the initial 0.862 seconds, I will need another 0.12 second before they come in contact, before this displacement between them decreases to 0. Therefore, 0.862 plus 0.12, it's going to be 0.982 seconds. This is going to be your total time after which both the particles come in contact. Now, I sort of explained it in a shortcut. The real way to do it, not a real way, but basically by formulating an equation, you can do it this way as well. That is a bit more lengthier and more complicated to understand. But I'll explain this as well. But this is the shortcut. What I mean by shortcut is, you know the relative velocity between both particles. You know the relative velocity is 3.8 meter per second. Because that's the extra bit of velocity P has in comparison to Q. Since both of those will now accelerate at the same rate after the 0.862 seconds. So after 0.86 seconds, they're both accelerating at the same rate. So they'll gain the same amount of velocity every second, which is why the initial difference in velocity will actually cover up this difference in displacement. This displacement will be covered up by the extra bit of velocity that P has. That is 3.8 meter per second. That's why I can directly find this time, that is speed is equals to d by t. My time turns out to be 0.12 seconds. Therefore, after the initial 0.862 seconds, I need more 0.12 seconds to cover up that distance between both the particles, right? So now, if you want to understand how to use it, how to find the time, extra bit of time, using the displacement equation, you can do that as well. But it will distill down to this equation only. So in case of the equation, displacement equation, notice what I'm going to do. So for the displacement of P, it's going to be 0.455 minus 3.7928 times T minus half A, that is acceleration, T squared. Now you will ask, where did this come from, right? This actually came from the displacement between them. So what I'm writing in this equation is compared to Q, what is the displacement P has? So compared to Q, the displacement of P is 0.455. That is the initial displacement between both of those. That is 0.455 meters. And I am asking the equation that after how long will this displacement turn out to be 0? That is, with respect to this point, that is this distance, how long will it take for this displacement to shrink down to 0? Right? So, with respect to this point, P will have this displacement equation. Because initially at time is equals to 0, what is the displacement of P? 0.455 compared to Q, compared to Q's position. After, let's say 1 second, this displacement is going to decrease. Notice the minus sign. This displacement will decrease, right? Now, in case of Q, what is the equation going to be? SQ is going to be, there is no initial displacement in case of Q because Q is in this position. So, compared to its own position, the displacement is 0, which is why we're not going to add anything over here, any constant over here. The reason we added a constant in case of the equation for P is because there is an initial displacement between P and Q, which is why we added that constant. However, compared to Q, to itself, there is no displacement, of course, which is why 0. Now, what is the initial velocity of Q in this position? Rest, 0, because it decelerated upwards and reached a velocity of 0 at this point, after that is 0.862 seconds. Therefore, at this point, your ut is also going to be 0, right? So I can write 0 plus half at, plus half at squared, right? Great. So now notice acceleration in case of Q is also going to be the same, that is downwards, right? In case of P, it was 4.4, if you remember, 4.4. In case of Q, it's going to be the same as well, 4.4 meter per second squared, right? Therefore, I'm going to write as 4 times 4.4 times E squared. Now, notice one thing, this is going to be negative. Why? Both of those are acting downwards, right? Acceleration for both particle P and Q is acting downwards, which is why we're going to add this negative sign. So it's acting downwards. Now, write both of these down. That is, equate SQ is equals to SP. That is, the displacement of P and displacement of Q is going to be equal. Meaning that at some point, both of their displacement is going to be the same with respect to this point. What that again means is at some point, both of these particles are going to meet. These point particles are going to meet together, which is why their displacement compared to this position is going to be the same, exact same, right? That is why we added this initial extra bit of displacement in case of the P's equation, right? So hopefully you can understand why this is arguably where most of the people I've seen not understanding where the equation comes from, which is why I'm putting so much stress on why I'm adding 0.455 meters, right? So at some point, both the displacement of SP and SQ is going to be exactly the same, right? Compared to this position, right? Because they're going to come in contact. Therefore, if I equate both of these equations together, I'm going to get 0.455 minus 3.7928 times t minus 2.2 t square is equals to, in case of SP, it's going to be again half 4.4 minus half 4.4 is going to be 2.2 t square. Now notice one thing. This 2.2 and this 2.2t is going to be cancelled off. And now, in this case, you're again left with the same equation that I had written initially over here. That is, t minus 3.7928t is going to be minus 0.455. So your t is going to be given by 0.455 divided by 3.792. So isn't this the exact same formula as P is equals to d by t? Yes, it is. Right? So if you had used that shortcut, you would have gotten the same answer as this, because this is going to give you 0.12 as well. 0.12. So you add this 0.12 to the initial time it occupied, that is 0.862 second plus 0.12, and this is going to be 0.982 is going to be your total time consumed before they come in contact. Now, in case of this direct equation, you would need to know that the concept of relative velocity, that since both of those have the same acceleration after this point onwards, the relative velocity between both of those are going to cover up the distance. So if you know that, you could have directly used the equation. Now, in the case both of those had different acceleration, you could have used, because both of those are accelerating at different rates. And if they had added that part as well, this question would have gotten even more complicated. So anyways, this was part B, the most complicated part of this paper. But yeah, hopefully you can understand what went on with this question. So if you don't understand, take your time and break this down into several parts for P, for Q, understand what's happening, understand where and when is it coming to rest and why, and try to understand this as well, the displacement equation. So if you have your upcoming mechanics paper, you may have to come across even more complicated cases. So, be used to formulating these displacement equations, right? This is going to help you. So anyways, that was part B, but you're also left with another part, that is part C, right? So part C is telling you, it's basically basic momentum, conservation of momentum. So it's going to be, the question is asking you, the particles coalesce on impact, that is, they're going to join together and find the speed of the combined particle immediately after the impact. Right, so they're going to join together and they're going to have a speed. They're both going to have the same speed, right? Okay, so what they're telling you is both P and Q, while moving down, after they come in contact, they're going to join together. So they're going to join together and are going to move with the same velocity downwards. So what is that velocity going to be? That's what they're asking you to find out. So for T, let's find out its final velocity. That is, notice for P, we had actually found out the velocity after 0.82 seconds, not after the total time. So total time, you now know, is going to be 0.982 seconds. So find the velocity for 0.982 seconds. That is, initial velocity is 0, because starting from the top, plus acceleration 4.4 downwards times your time, that is 0.982, and your final answer turns out to be 4.328 meter per second. 3208 meter per second. So that is the velocity of P after, when they come in contact. Now for Q, do the same. Find the velocity of Q. That is, initially is 0, because it's starting from, it went up, paused, and falls down. So when it pauses, when it comes to rest, from that point onwards, it's going to accelerate down. So from that point onwards, what is the velocity it gains? That we're going to find out. that is 0, 0 plus 4.4 acceleration downwards times 0.12, that is the amount of time after which they come in contact. Because notice for Q, it moves up, it consumes 0.86 seconds, then it pauses and moves down for 0.12 seconds again before P and Q comes in contact. So I'm considering from this point, that is V is equals to 0 to V is equals to 0.528 meter per second. For this position, till this position, 0.12 seconds, what is the velocity gate? It's going to be 0.528 meter per second. That is the velocity of Q. That is where they come in contact. So now, formulate the equation, that is sum of momentum before collision is equals to sum of momentum after collision, that is in the same direction. So m times velocity plus 2m times velocity is equals to 3m, because 2 plus 4, 3mv. So now cancel off all the m's and you're left with the velocity of the particles. And this velocity is going to be the velocity of both the particles since they're moving together. Okay, so that is going to be your question 7 from Winter 2142. Hopefully, you could take something away from this video. So, I have a couple of other questions that I would want to solve. That is from mechanics paper. And I'm going to try and solve it before the exam. So, yeah, see you in the next video.